You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. For over 75 years, Batesville Products has been engineering, casting, machining, inspecting, and polishing aluminum castings for over 70 industries nationwide. In today's episode, we'll continue to share our experience and industry secrets. Casting Class is in session. So the question that we see in the industry a lot is really starting at the end, working backwards, understanding what your end goals are, and whether it fits within, the permanent mold process, whether it's an extrusion, whether it's a die casting or sand casting.
So, we're going to, dive through here and, look at some different processes. We're not going to cover every type of process that's out there to manufacture parts, but we're going to look at some key processes. Where is sand casting a better option? Usually quantity is the driver of that. If you have a low volume part that has some very unique features that, can only be achieved, with casting, sand casting does lend itself to simpler geometry. Tooling cost is a little bit cheaper, especially comparing to permanent mold and die casting. But you don't get the details that you would get from a permanent mold, die cast, or an investment cast process. Investment cast, a lot of times people are looking at high surface finish, high details, but low quantity. Usually that's the direction I go. So in the low quantity world, sand casting is definitely the champion in that.
I think a point there too that's really critical again from that previous comment is really understanding what your ultimate goal is. So if your part's hidden, your surface finish requirements really aren't super high. You're really looking at how long does it take for you to pay off that tool. What kind of surface finishes your end customer looking for, and really understanding whether sand casting's a fit, permanent mold, die casting's a good fit or not.
Yep. Usually sand casting is easy to hide that tooling cost into the piece price.
Absolutely. And on that note, where's die casting a better option? A lot of times the quantity for sure drives die casting versus a lot of these other processes. We see a lot in automotive where they're running tens of thousands, hundreds of thousands of parts a year. But it's definitely looking at the type of quantity that you're running, the surface finish requirements that come with that quantity. So if you're running these high volume parts, you're force feeding it into these molds. Solidification time really becomes a key factor with the quantity and the type of parts that you're running. So in die casting, you often see a lot of different parts, again, that are force fed into these molds, have thinner walls and really aren't too concerned with really the pressure tightness or the solidification of the part. That also gets you kind of the next topic there of thin wall and the way it's drafted. In die casting, they can get away with a lot thinner walls and less draft due to the forcing of that metal into that mold. So really understanding, what type of draft do you need? Are you looking at straight up and down walls where you can either cast that in closer on a die casting, or are you looking at on a permanent mold casting? You need denser walls for more of an explosion-proof type casting.
Yeah, like I said, you can achieve those thinner walls on a die casting, but you won't get the metal density when compared to permanent mold and sand casting a little bit.
Absolutely
the same.
Yeah.
But just kind of elaborate on that a little bit. We talk about quantity on die casting. There's a lot of automotive-esque parts. High volume, 200, 300,000 pieces per year that are definitely die casted, and die casting is the only option in order to keep up. But there are some automotive parts out there that are permanent mold cast, example, or wheels and some types of transmission parts, because you can get that leak-proof characteristic from a permanent mold.
Absolutely.
Where if you were driving a car with die-cast wheels, you may not make it down the end of the road without the air leaking out, or you have to do quite a bit of sealing in the metal to get it to seal up.
Die casting lead times tend to be a lot more drawn out than a permanent mold or a sand casting. And a lot of times it's because of the components that go in those type of molds.
Right. A lot of water cooling on a die cast, it looks, it's an engineering nightmare, for a die casting part. There's a lot that goes into making sure that that part's going to be produced quality wise and quickly, right? Die casters, usually are driven by that, that time crunch a lot more than permanent mold and sand casters.
Absolutely. Absolutely. And there's prototype processes where you could get, one-off parts a lot quicker. But ultimately, when you're looking at production run, higher run type quantities to suffice, the end customer here, there's definitely better routes than those prototypers to be more cost effective for sure.
So, moving on, when is machining a better option? Typically, machine parts, they're low run quantities, they're high tolerance. They can use a wide variety of metals that, isn't quite possible with the casting industry. The casting industry, there is a variety of metals we can use as a caster, but, it's not as diverse as a machine operation. Normally, machining operations, especially on higher volumes, they're near net stock shape. They don't remove as much as material. If you start as a cube or a circular shape, at the end of the day, usually it looks like a cube or a circular shape because they're not removing as much material. Whereas a casting operation, we cast near the net shape. If you look at the picture that's on the slide deck, a lot of the features that are painted in green, they're cast into the final shape. There's no machining on it. There is machining on this part, but only the machining of the critical features to the customer are machined. Think about, I do have a part here. It's a we call it a can, but it's a hollow shape. That part, if you were to machine it, you would have to remove 80% of the material in the cutting operation, where in the casting operation, it's almost a finished shape when it's done.
Yeah, and I think in the casting industry, you see a lot of this. So we see people come across that have billet that they're machining 100% out of, and they're 70% lost material. So casting in general is typically the better route. Again, after you get out of that prototype life stage and you really get into the production runs there.
Right, but when you're doing your prototyping and you are thinking in the direction of casting, we need to make sure that prototyping is done.
Absolutely.
Or the intended process. And as engineers, we may use machining or other casting methods as our prototyping platform. But at the end of the day, if we're driving towards a sand casting or a die cast or a permanent mold or a machining, we need to make sure our prototypes are tailored towards that end design.
Absolutely. Understanding that end goal in mind for sure. Yeah. We'll continue on here. So Justin kind of hit on this a little bit here, but really getting into the full benefit of permanent mold casting. So he had mentioned the near net shape, which you would get minimal secondaries on. By that, what we mean is a lot of the machining. So we just talked about machining out a billet and 70% loss of material. So what we see a lot in the casting and permanent mold casting is we are able to cast really near net shape coming off the press and doing kind of the minimal secondary machining operations to really develop a good casting ready to assemble for our customers. So across the industry, that's something that's being looked at. In permanent mold casting for sure, because it's less prone to failure than sand casting or die casting. And the reason behind that is, in sand casting, you have a lot of porosity potential or shrinkage potential, or even shifting in the tolerances just because you're building out of a sand mold. So you have to repeat that pattern. In permanent mold, they typically use a steel mold to develop that actual mold, the fixture they pour into, and that really develops permanent mold casting capabilities and tolerances across the life of that part. So in die casting, where you see a little bit different too, is again they're forcing in there. So you have a lot of that same porosity or shrinkage possibilities that you would see in sand casting as well.
Yeah, I think, when you're comparing sand casting to permanent mold, tolerances are usually 50% more on sand castings. And if you're machining the material away, it's usually sometimes that's not a problem. But if you're trying to get near the net shape and your process allows that, then that's acceptable or that's not desirable, depending on which direction you want to go. But where permanent mold I think really shines is grain density of the aluminum.
Absolutely.
Or the alloy you're casting, where you can get a lot of those features that other casting methods can't provide.
Absolutely.
Let's talk about some unique features that other processes can't provide. Some sand casting, die castings can provide some of these examples, but sometimes it's not as prevalent in the other two processes. Cast and inserts, the example in the picture where this process, the part was casting in a stainless steel tube into this product here. It's a light fixture. The purpose of that stainless steel tube is to protect the wireway from removing the sheeting on the electrical wire, and then having a failure in the field 30 feet up in the air, and then a boom truck would have to come fix the light fixture. This can also be chilling, cooling, a lot of refrigeration applications or heating applications, valving where inserts can be put in there, steel inserts can be put in there if stronger threads are required. Sand casting can do the same thing. Die casters usually, they shy away from that, putting features into that. They don't want to slow down their process. Overmolding is also possible with urethane or rubberized coatings on the outside. And thicker cross sections can be achieved with permanent mold, also sand casting. And then, as we said, metal density compared to other compared to sand casting and die casting.
Yeah, I think we see, a lot of the casting inserts and overmolding in medical and lighting industry for sure in the permanent mold market. We talked about the part you see on the screen there with the lighting industry, but it really allows for the customer to really drive wires through there, not really tear up any of the parts inside, and really create the end goal again in mind of what that customer is looking for.
Right? Or you at the end of the day, the engineer might say, I need really strong threads, but I need a lightweight part. Well, let's cast in a steel insert, get my strong threads, and then I have a light part at the end of the day because I'm using an aluminum alloy.
Absolutely. Absolutely. And you talked on the previous slide about the grain structure here. Again, big in medical industry, but we see it a lot in, the industry across, all sorts of different types of customers and clients, because what they're trying to look for is, again, a denser, nice surface finish type product.
Hey guys, we got a quick question about the ASCAST inserts. How much easier is that with permanent molds, and is it more problematic with other methods?
Sand casting, you're inserting that steel insert or whatever you're inserting into the sand mold, and it's made of sand. There's ways to strengthen the sand to make it more rigid, so you can put that insert in there, and it's possible. It's a little bit more prone to little pieces of sand falling off and contaminating the metal, but it is possible. Die casters really don't want to mess with it. They're usually highly automated, robotically poured processes, and they don't want to mess with an operator going in and setting a little insert into the mold every cycle.
How does permanent mold minimize those secondaries needed? So we mentioned earlier a little bit about the near net shape coming out of the mold. So Justin had hit on it a little bit too on the, compared to sand casting and machining. On sand casting, there's more tolerance needed for those sand castings where you may have to come in and really machine a lot more off. Similar, on the machining side of things, really understanding, again, the end goal of mine that we're not, seeing a lot of draft on those parts that they got to come in and machine off again. We're casting, you're seeing the casting to near net shape again, so the machining is very minimized. So the limits in again, surface finish that you see from a permanent mold casting, where it's casted into a steel mold, definitely high end surface finish compared to sand casting. Justin had mentioned a lot of the porosity potential that you see from sand. So from a permanent mold perspective, where you're casting into a steel mold and a permanent surface, the surface finish on those parts become very, very high end. On top of that, we see a lot of, again, the casting features versus machine features. So there's a capability on permanent mold side and seen in the industry that using pull cores or things of that nature to really hollow out certain areas, again, pulling the part off the press that is a near net shaped part and really developing from the back end and eliminating some of that machining by the way we cast it.
We're looking to machine, as an engineer, what's important to us. Machining is more of a tighter tolerance process. Instead of machining the whole part, let's machine what's critical to the customer. It kind of leads us into, understand, what's important to the end user. The biggest thing that as an engineer I come across is, a lot of times other engineers or designers, they're asking for things they really don't need. They put on a standard tolerance or a surface finish requirement that looks good, but is it achievable at the end of the day, or is it required? Is that feature visible to the end user? If not, and your design allows for it, can we relax those tolerances? It's understanding what's critical and important. Like I said, less is steady. And then this also, affects time to market. If your design is flexible, we can massage the tooling design and get your product to market quicker and faster. Biggest problem that I experience as a manufacturing engineer is over-designed or under-designed parts that jeopardize manufacturability. And, explaining that, to a potential designer, what needs to be changed, making sure that we're not over designing it. One of the things that, to me is the Achilles heel a lot of times as a manufacturing engineer is the general tolerancing block.
Yep.
They'll put on the general tolerancing block that's very specific to their company and has very tight tolerances. It's usually specific to machining.
Yep.
Because everyone's very understandable a lot of times as an engineer what machining tolerances you can achieve, but maybe not so much educated on casting. And the first thing we, as a manufacturing engineer, I have to go to another design engineer is, hey, we can't achieve what you're asking for, and it adds time to the process. Or adding tolerances to features that aren't necessary. A good example is I worked on a product recently where I did not pass the first article of inspection on a very tightly controlled hole. And I went to the customer and I was trying to understand the feature and what was it for, and are these tolerances really required? And at the end of the day, it came out to be a ground wire screw hole where, it really could have been off a half inch and not affected their product at all. But we were working with a very delicate casting that at the end of the day, it was hard to machine that feature in without the part flexing a little bit.
Yeah, I think it goes back to a comment you made earlier too. Don't over design. There are definitely critical features,
of course,
on that part. But when it goes back to the tolerancing block, just really understanding, really call out what those critical features are. It could be surface finish, it could be, the machining that you're doing on the part.
You might have an O-ring groove or something specific to a motor housing that's very important.
Yeah.
But the overall shape is not as, as concerning to the overall, product design.
Absolutely.
At the end of the day, the biggest thing is don't over design and have some flexibility if possible. Sometimes designs are very firm, and we know that just needs to be communicated to the foundry engineer.
Absolutely. I think what you hit on there, what's critical is really, highlighting again, don't come in over design, really look at key components that you're developing this product for, and really working back and forth with the engineer to make sure that those are met. So hit on it a little bit before, but creating a functional prototype, it's seen a lot in the industry that there are prototypes created out of 3D printing. You can do it out of a sandcast mold that's 3D printed. You can do it out of a sandcast one-off mold. It's seen a lot in billet and machining that we talked about earlier. But really getting involved again with that engineer and that end goal in mind of, is this going to casting process, and really understanding, okay, we are doing it out of something to get a quick prototype, really understand, get form, fit, feel, and function in our hands, but really understanding the end goal in mind and working with an engineer to really understand that. So in doing that, you don't want to jeopardize the part's integrity at all. You mentioned it in the previous slide, don't ever design. So you can design something, and just because you design it doesn't necessarily make it manufacturable. So again, if you're going through and you're machining a part out of billet, or you're prototyping it some other way, keep in mind the end goal and really develop it from that perspective, and reach out early on. Start talking to engineers early on from different vendor possibilities to understand what makes sense, because permanent mold, sand casting, die casting, extrusions, there's different processes. Not everything fits with every process.
Right. Yep. Like I mentioned before, as an engineer, we've all failed at drawing something up, a 3D model, and at the end of the day, we stand up, we're real proud of our design. Then we have to stop and go, okay, how am I going to make this? What process fits this?
Absolutely.
But kind of hit on the prototype world. There's some crazy technology out there. They're even 3D printing sand molds right now.
It's nuts.
So you can, hey, I need 5 of these.
Yeah.
Get 5 molds printed off, and then you can get some samples real quick.
Yeah, and to the prototype point, it's quick and fast. You get a form, fit, and function part that you can hold in your hands, see if it's what you like, and move forward from there. Really understanding the tool itself. There's different processes in the industry, and the way the parts are casted. Different casting industries set up their molds and their presses in different ways. So really understanding the types of coating applications. So if you're in permanent mold process, there's different coatings that do different things that are sprayed on the molds. Anything from cooling certain features or areas to help an air get out, but to really help make a good casting. So understanding what that is and what those are up front.
And on the production floor, the foundry has to be able to get those coatings into the mold.
Correct.
So if they can't spray that coating down in that really deep crevice, the tool is going to wear prematurely.
Absolutely. And another thing to hit on is how that part's ejected. So in the permanent mold industry, simple standard tolerance is 3-degree draft. It just helps the part, get out of a steel mold and really keep that integrity of the part. Other types of castings have different surface finish requirements, have different draft angle requirements. So really looking at how can the part be ejected from a permanent mold or a steel mold. And just hit on it, but the next line there too, the surface finish requirements. Is the part going in the ground? You're not going to see it. May have some critical machining fixture tolerances there, but maybe the surface finish tolerance isn't.
Or, a lot of, parts where they're visual only from one side.
Yeah.
Let the foundry understand that, hey, that surface is very critical, so they can focus specifically on that surface. And I'm not saying that, let the rest of it go to the wayside, but, maintain the focus on what's important.
Yeah, really make it your A surface, your really cosmetic surface that you would call it. So definitely a good place to start when you're trying to understand whether you actually need metal casting or not. Again, look at the end goal and go from there.
Thank you, guys. That was some great insights, and thanks, Justin. Thanks, Tim. We appreciate it.
Thank you. Appreciate everybody's time.
You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. Be on the lookout for our next casting class on the first Wednesday of every month. Until then, you can find more resources like videos, written guides, and case studies on our website, batesvilleproducts.com. That's batesvilleproducts.com. See you next month.